Let's try a demonstration of the positron showing that quanta in the positron spot participate in 3 different proton bit cycles. If I press enter at this point, having started the Binary Mechanics Lab simulator, hotspot.exe, a dialog box will appear where we can choose an input file. It won't be shown on the screen because the Windows capture does not include it. So I'm going to choose positron3.mat, and it's going to ask for a randomization seed. I'll press enter, which means use the timer. Add more objects, enter equals no, I'll press enter. Experiment number, press enter, that means none. We're going to use the press enter for the default bit operations order. I'm going to press the O key during tick 0. Here we go. The bits that started out in the positron spot have separated into 3 proton bit cycles. I'm going to press the C key to pause it on a cycle of 21 ticks. That's indicated up here, pause on cycle. So you see the 3 quanta in the original positron spot have separated out into the 3-bit cycles in adjacent spot cubes of the proton bit cycle. So what do we have here? Let's take a look over here. We're looking in solid mode at both M-type bits and L-type bits. If we press H, we'll get a help screen. Here's the bit operation order, SUVF. And let's see down here, we have 3 light bits, L-type bits. And we have 0 charge because the L bits don't have charge. There is no particular particle indicated here. And we see that at this particular point in time, there's one of these bits is in the right-handed red, green, and blue dequark locations in the respective 3 proton bit cycles. This is showing their mean position and the standard deviation. There's nothing for the electron positions because there is no bits in the electron bit cycle. This is the amount of displacement from the previous tick, and here is the distribution of 1 quanta each in the right-handed spots. At the very bottom here is our output file, is going to be in the INI directory, and it's positron3.csv, so named because we input from the INI directory a pre-existing matrix file, positron3.mat. Let's unpause it, pressing spacebar now. Okay, so it's going to run, and it's proceeding through the 3-bit cycles. And we're going to pause on cycle. A cycle would be 21 simulator ticks, because that is the duration of the proton bit cycle. And already, let's see what's going to happen next. Will it pause? Oh, it paused, but not exactly where they're all back to the initial location. Okay, so I'm going to press the W key here, which will unpause it, but also put it in single step mode. All right, press space key. Aha, there we are back to 0. Here we have the charge is 1 because there are 3 M-type bits. The total energy is 3. Among the particles, we have met the definition for a positron which requires 2 or 3, but we have 3 now, M-type quanta in the particle. And we can see here the 100% of the energy quanta are in the positron spot. There are no L bits of any kind at this present moment, so I'm going to press the W key to take it off of single step. And we're watching it go through another proton bit cycle again. Maybe I should just be quiet and let you see it. This is, of course, repeating what we had before. While we're waiting for it to complete the cycle, notice that over here we have 0 events in the vector and scalar bit operations. Why is that? Because there is the requirement of an adjacent potential bit, either an M bit for electrostatic or an L bit for for magnetic. Okay, I'm going to put it to single step now because it looks like it's getting close to going back to the original positron spot again. There we have it. Okay, I hope you enjoyed this video. Have a very nice day, folks. Thanks for watching.